Mark, it is a real privilege to be here today, especially in the presence of Mrs. Green, to help you celebrate the opening of this magnificent new facility. It's also been a privilege for me to spend some time earlier today with Dean Quatrano and several of his colleagues, learning a bit about many of the awesome activities that are going on here at Washington University's School of Engineering and Applied Science. But it's especially a privilege because I've always wanted to be able to stand in front of a Washington University audience and tell you that, in my view, America in modern times has produced no better academic leaders than Mark Wrighton and his predecessor, Bill Danforth, and no greater human beings. You guys are really lucky. A year or two ago, the great filmmaker Ken Burns produced yet another extraordinary documentary called America's Best Idea, Our National Parks. Well, as great an idea as our national parks are, I don't think they're America's best idea. In my opinion, America's best idea was the establishment of this broad system of public and private research universities with access to great numbers of our citizens. Because these institutions do more than the traditional role of colleges and universities in archiving knowledge and passing it on to the next generation. What our American research universities do is create opportunity. They create opportunity for our graduates by enabling them to be productive citizens, by preparing them for the workforce, and by introducing them to the life of the mind. They provide opportunity to business and industry. First of all, obviously, by preparing employees for them to hire, but also, and increasingly so, being a key source of ideas and indeed even new products and new services. And as is exemplified around here, America's research universities provide opportunity for states, regions, and nations. They are today key to building vibrant economies, to providing security in many dimensions, and to providing a quality of life that industry and business need for themselves and their employees. Now, the main process by which we do this, of course, is what we call learning. And as I've seen today and heard about today, as well as through the rest of my career, learning occurs in universities like Washington University in many ways. Obviously, we pass along knowledge, we teach, but we also learn by research and scholarship and by experience in an ever-increasing dimension and an ever more complex world. We also, in universities like this, are part of America's innovation system, or innovation ecosystem, as many like to say, a rather uncoupled and somewhat informal flow of people, ideas, and money among universities, governments, major industries, startups, and investors. This innovation system does several things. First of all, in the university world, our education and research provide new knowledge and technology. We also provide the next generation of people who will yet again move forward by creating new knowledge and new technology. And they then go to industry, which helps them to move these new technologies and new knowledge into the real marketplace as new products, processes, and services. Now, I have found a lot of times in talking to non-academic audiences that they think, well, that's nice, but you're not really all that important in this. And so I've gotten in the habit carrying around a few of the university-based innovations, a few of the important innovations of our time that have come primarily, and in some cases exclusively, from our research universities. Computing, the laser, the internet, numerically controlled machinery, the fundamentals of the GPS system, the deployment of the World Wide Web, the genomic revolution, and most of modern medicine. My point, if you take nothing else away, is that this is serious business in which we're engaged. I don't think there's a job in America that is not based on utilizing one or more of these innovations that have stemmed from our research universities. But the world changes, and I wanted to give you a couple of thoughts about changes in the world that we all have to recognize, and about changes in engineering that are beginning to be played out here and elsewhere. First of all, the big thing that's changing in our world in many ways is the fact that we're realizing how much we all share. Our planet has a population that's beginning to approach 9 billion people. We have a shared environment. We have shared challenges. We have shared resources. We increasingly have shared knowledge, and we certainly have shared humanity. And this world is also increasingly networked. Networked in ways that are changing virtually everything profoundly. So I think that in such a world, we have to do two things that sometimes sound like they're counter to each other. We have to compete against people all around the world, and we have to cooperate with people and organizations all around the world. To me, competition and cooperation in the 21st century are sort of the yin and the yang of the new global reality. And I think one of the things I've been very proud to observe here today, and also from what I've learned from Mark and John McDonald in other situations, is how much you are doing to prepare your students experientially to work and live in such a world. But there's also change closer to home. In the 20th century, makes me sound really old, but the 20th century, when most of my career played out, we had stovepipes everywhere. Scientists discovered, engineers created, doctors healed. And that was kind of what we did. But in the 21st century, it's all about integration and convergence. Science, engineering, and medicine are totally interdependent today, and they're blending in amazing new ways to find synergies and do things that contribute to each other's endeavors in ways that we could hardly have imagined just a decade or so away. The 20th century, the role of computing, I believe, is also going to change in very dramatic ways. In the 20th century, computing was mostly about information flow, storage, transmission, and analysis of data versus IT, and the use of the internet and the World Wide Web. In the 21st century, computing is going to increasingly be about actually generating knowledge, not just storing and transmitting it, but generating knowledge through modeling and simulation at extreme scales and through new kinds of interactions of information technology and computing with the physical world. It's going to be about knowledge sharing, about distributed discovery, and I mean distributed around the globe, distributed discovery, operation, and innovation. And also, when I think about change in engineering and in what we have to do for our students and colleagues, I think about what I'm hearing as changes in the language of engineering. When I went to school, the words we would have attributed to the field of engineering would be things like force, size, modulus, temperature, speed, tolerance, precision. These words are all still here because they're the descriptors of what I would call basic or the fundamentals of engineering. But today we also hear words like scale, state, integration, resilience, affordability, scope, complexity, architecture, evolution, and social context. These to me are the descriptors of the modern world of engineering systems, and I know that systems is a quite dominant theme here at Washington University. But equally exciting, I hear today from engineers, cellular circuitry, adaptive immunity, reprogrammable bacteria, synthetic biology, natural adhesives, bacteria-laced concrete, integrated cancer research. This is the language of convergence, integration of biology, life sciences in general, and engineering. What a fabulous frontier that is describing. And finally, there are some other things that I hear, or at least that we at the National Academy of Engineering hope to hear more, and I have today. Things like engineers are creative problem solvers. Engineers make a world of difference. Engineers help shape the future. Engineering because dreams need doing. Engineering is essential to our health, happiness, and safety. These come from a program we at the Academy call Changing the Conversation. Because, as those of you who were in attendance at the excellent talks and discussion earlier today know, we have a problem, a big problem, a crisis indeed in this country of not inspiring and bringing enough young women and men into fields like engineering and science. And part of the problem is we have a miserable image, and we have to get young people to understand the power, the excitement of engineering, and the fact that if you really want to make the world a better place, there's no better pathway through which to do it. So in conclusion, let me simply say that America's research universities, like Washington University, provide opportunity to graduates, to business and industry, and to states, regions, and nations. We function as a critically important part of our nation's innovation system and must continue to enhance the interworking of academia and business through research, innovation, and increasingly through entrepreneurship. We must recognize and prepare our students for the networked world in which we must simultaneously compete and cooperate, and more importantly, to work in a world of finite shared resources in which sustainability must become the sine qua non in all that we do. We must also rapidly evolve our education and research to recognize the convergence and integration of engineering, science, and medicine, and the increasing importance of systems perspectives, analysis, and activities. The fact is that in many dimensions, the St. Louis region, Washington University, its engineering school, and its electrical engineering departments in particular have indeed been among the leaders of many of these trends, and I believe have an extraordinarily good field of opportunity ahead. So let me leave you with these thoughts. Despite the pervasive economic and national problems that we face, you are the solution. Second point, this is without question the most exciting era in human history in which to be engaged in engineering and science. And third point, in America, we cannot solve our problems. We cannot provide coming generations the opportunity they will need, and we cannot sustain great universities without enlightened and generous private philanthropy. So it's with a sense of excitement, gratitude, and privilege that I am here today to participate in this dedication ceremony to celebrate the convergence of such philanthropy and opportunity in the wonderful new Preston M. Green Hall at Washington University in St. Louis. Thank you very much.